Now let's take a look at how to add and subtract vectors. It's actually quite simple. To add and subtract vectors, you're going to add the x components together, and you're going to add the y components together to get your new vector. We can do this both graphically and algebraically. So if we look at our two given vectors, our vector u goes back 6 and up 3, and our vector v goes forward 2 and up 5. So if I want to add those two together, then I'm going to go ahead and take my vector u, negative 6, 3, and we want to add to it my vector v, which is the vector 2, 5. When we add those two together, negative 6 plus 2 is negative 4, and 3 plus 5 is 8. So algebraically, we can find our vector negative 4, 8. Now let's find it graphically. We can start our vector u anywhere. All it has to do is travel back 6 and up 3. So I'm going to go ahead and start it down here at negative 6, 0. And, 0, negative 6. And if I want to go ahead and put my vector u in, my vector u goes back 6, up 3. So I can graph my vector u. Then I want to add onto it, so onto the end of vector u, I'm going to add vector v, which goes forward 2 and up 5. 1, 2, 3, 4, 5. And my resulting sum is how do I get from start to finish? So when I graph that in, I can see that I went back 4 and up 8. We can also subtract vectors. So when I subtract vectors, when I distribute a negative, it's now going to go in the opposite direction. For question number 4, let's go ahead and again find this algebraically first. We're going to start off with our vector u. So we're going to take the vector, negative 6, 3. And this time, we're going to subtract from it our vector v, which is 2, 5. So when we distribute that negative, negative 6 minus 2 is going to give me a negative 8. And 3 minus 5 is negative 2. So let's go ahead and look at this now graphically. We can start our vector u anywhere. So let's go ahead and start it at the origin. We know that vector u goes back 6 and up 3. Now, if we're subtracting off if we're subtracting off v, that used to go forward 2 and up 5, when I distribute that negative, it's now negative 2, negative 5. So I'm going to go back 2 and down 1, 2, 3, 4, 5. And you can see that the resulting vector is back 8 and down 2, just like we found algebraically. You can also multiply your vector by a scalar multiple. In question 5, we want to take 2v minus u. So we're going to take 2 times the vector 2, 5. And then we want to subtract off our vector negative 6, 3. So if we do this algebraically, we're going to distribute our 2. So that's going to be the vector 4, 10. And if you want to, a lot of times it's nice to distribute that negative and change that to a plus. So if I distribute that negative, I'm going to have a 6, negative 3. And so that's going to give me a final vector of 4 plus 6 is 10, and 10 minus 3 is 7. So we can find our sum or difference algebraically. Now let's find it graphically. It says to start off with 2 v's. So I'm going to start way down here at the bottom, 0, negative 10, and I'm going to travel v twice, which means that I'm going to go forward 2 and up 5 once, and forward 2, up 5 a second time. Once I've traveled 2 v's, I want to now subtract off my vector u. So instead of going negative 6, 3, when I distribute that negative, it's now going to be 6, negative 3. So I'm going to go forward 6 and down 1, 2, 3. So there's the vector negative u. Notice it goes in the opposite direction. And so my resulting vector goes forward 10 and up 7. We can also find our sums and differences and our magnitudes in our I and j form. So for 6, 7, and 8, we're given vector u, which is negative 4i plus 3j, and vector v, which is 5i minus 7j. If it asks me to find it in component form, that's with my pointed parentheses. So let's go ahead and start off with taking our vector u here and multiplying it by 4. So 4 times the vector negative 4, 3 minus 3 times my vector 5, negative 7. So if you want, let's go ahead and distribute that 4 and then distribute that negative 3. And that's going to give me negative 16, 12 plus negative 15, 21. And so when I add my x components together, we get negative 31. And when I add my y components together, we get 33. So that results in the vector negative 31, 33. Looking at 7 and 8, they're very similar to each other, but quite different. Both of them are asking a question about magnitude, length. But for question 7, we want to find the vector u minus v first, and then find its magnitude. Versus in question 8, we want to find the two vectors, u and v, find their magnitudes, and subtract their lengths, their magnitudes from each other. So for question number 7, let's go ahead and start off by finding the vector u minus v. So we're going to take the vector negative 4, 3 minus the vector 5, negative 7. And my vector u minus v is going to be the vector negative 9, 10. Once I found my vector, I want to now find its length, its magnitude. And so if I want the length of this vector, I'm going to take the square root of its x component squared plus its y component squared. If you want, you can leave it as the square root of 181, or you can write it as a decimal of about 13.45. For number 8, it's a little bit different. We want to find the two magnitudes and subtract them from each other. So let's find the magnitude of vector u, which is going to be the square root of negative 4 squared plus 3 squared. That's going to give us the square root of 25, which is 5. Then, if I want to find the magnitude of v, I'm going to take the square root of 5 squared plus negative 7 squared, and that's going to be the square root of 74. So if I want to find the difference of these two lengths, I can take 5 minus the square root of 74, and you can leave it like that, or you can write it as a decimal.